One of the key problems in computer vision is recovering the three-dimensional structure of a scene from its images. Let's think about this for a second. You have a scene that is defined in some world coordinate frame, and at the end of the day, when you've reconstructed the scene, you would like to know where each point lies in this world coordinate frame, say in millimeters. But what you have at your disposal are images of the scene where points are measured in terms of pixels. So in order to go from images to a full metric reconstruction, we need two things. The first is the position and orientation of the camera with respect to the world coordinate frame. These are referred to as the external parameters of the camera. And then you want to know how the camera maps via perspective projection points in the world onto its image plane. These are referred to as the internal parameters of the camera, such as its focal length. So determining the external and internal parameters of the camera is what is referred to as camera calibration. So we're going to develop a method for estimating the camera's internal and external parameters. Before we can do this, we first need a model for the camera. And this is what we refer to as a camera model or a forward imaging model, which takes you from a point in 3D to its projection in pixels in the image. And we would like this camera model to be a linear model. We know that estimating linear models is much easier than estimating nonlinear models. And it turns out that the linear model we come up with is a single matrix called the projection matrix. So now, with the projection matrix in place, we can develop a method for camera calibration. And the way we do this is that we take a single picture of an object of known geometry. And that is all we need to fully calibrate the camera. In other words, to determine the projection matrix in full. What is even more interesting is once we have determined the projection matrix, we can actually tear it apart to figure out both the internal parameters of the camera and the external parameters of the camera. These are called the intrinsic and extrinsic matrices. So at this point, our camera is fully calibrated. And we would like to end with a simple example of how we can use a calibrated camera to reconstruct a three-dimensional scene. For this, we discuss what is called simple stereo. In this case, you have a camera that is in a particular location and a second camera which is displaced in the horizontal direction by some amount. These are identical cameras. We assume that these cameras are calibrated. And using these two views of the scene, we show how we can recover a three-dimensional representation of the scene.